first lesson on atomic structure, which is going to be about the periodic table and the structure of the periodic table. So the periodic table is what chemists use in order to keep track of all the elements that are known. The aim for this lesson is for you to understand the periodic table. And in terms of success criteria, what we would hope you would be able to do by the end of this lesson is to identify what we call periods and groups in the periodic table, identify where to find metals and non-metals in the periodic table, to state the names and properties of elements in groups 1, 7, and 8, because those groups have special names, and also to give the name for the middle block of elements on the periodic table. So the periodic table is where you find information about elements. An element is a material, a chemical, a substance made from only one type of atom. It cannot be broken down into anything smaller. So if you have something that's an element, you might be able to break it apart, but all you're doing is breaking it down into smaller pieces of itself. Like if you rip up a piece of paper, each piece of paper is just a smaller piece of paper. That's exactly what elements are. There are so far 118 elements, and the most recent of these was discovered in 2016, so quite recently. Chemists classify the elements, so that's group the elements, and arrange them in something called the periodic table. Now, the periodic table looks like an interesting shape, but it's divided into things we call columns, which is the ribbons going downwards. So you can see in that picture on the left, the vertical colours, the red, the orange, the yellow, green, etc. Those are groups. So if you start at the top of a column and go down, that is a group. Each row in the periodic table is called a period. And that's where it gets its name. The periodic table is because it's a table of rows called periods. So if you're going down, it's a group. If you're going across, it's a period. Now, each group of elements, the reason they are in that group is because they have the same chemical properties. Now, chemical properties just means that they respond the same way to the same things. So, for example, elements in the same group might all react the same way with water. They might also all be in the same physical state, and they might have other properties like an ability to conduct electricity. And even though the periodic table is split into groups and into periods, it can also be divided into lots of other things. So we can look at the periodic table and think of how the elements, some of them are solids, some of them are liquids, and some of them are gases. We can also think about elements as being metals or non-metals. And we have a lot of naturally occurring elements, but some of the elements are man-made. So that is another way of dividing up the elements. So this is what the periodic table looks like. You can see all those columns and which are groups, and you can see all the rows which we call periods. Each individual box represents a different element. And you can see the main clear thing inside each box is a symbol, either one or two letters. And those letters are what we use to represent the elements. It's kind of like the alphabet for chemistry. Underneath the big symbol in each box is the name of the element. A lot of the symbols and the names relate to one another. For example, the three boxes I've got highlighted in blue there, the C, that stands for carbon, the N stands for nitrogen, and the O stands for oxygen. It's quite straightforward. The symbol is the first letter of the name. But that's not true for every element on the periodic table. In fact, quite a lot of them have symbols that don't seem to relate to the name. Two really good examples of this are the two I've just highlighted in yellow. We've got Ag and we've got Au. And these are two very famous metals. Ag is silver and Au is gold. Now, those symbols don't seem to have anything to do with the names. But in the past, we're talking a very, very long time ago, the names of silver and gold were different. Silver was called argent and gold was called aurum. And so the symbols come from their old names, not their new names. And that seems to be true for a lot of the periodic table. If the symbol and the name don't seem to have any relationship to one another, it's because that element has changed name at some point. Now, luckily, you will always have access to the data booklet, the National 5 data booklet. And on page 7 of that data booklet, you have a list of every single name of an element, and beside it, you've got the symbol. So if you ever get stuck and you know the name of an element but you can't remember its symbol, look at page 7. And also, if you've got the symbol for an element but you don't know what its name is, you can also look at page 7 of the data booklet. Now, some of the elements on the periodic table have been named after famous scientists. And I've got three good examples highlighted in red at the bottom. So the first one there, Cm, that element is called curium, and it is named after Marie Curie, the famous female chemist and physicist who discovered radioactivity. And now there's a famous cancer charity named after her because her discovery caused her to have cancer. That's why those two things are related. The second one, the Es, that's called einsteinium, named after Albert Einstein, who came up with the theory of relativity and that equation that most people have heard of, E = mc squared. But the final box there, if I told you that's called Mendelevium, you probably wouldn't know who Mendeleev was. Well, Mendeleev was the person, the scientist who actually created this version of the periodic table that we use. So he has now had an element named after him, which makes sense because he created the table, he should have his name on it. Now, as we said, one of the goals for this lesson is to learn the names of some of the groups in the periodic table. What we're going to look at first is group 1, so the one highlighted in dark blue. Group 1, and group 1 is called the alkali metals. Now the alkali metals, firstly, they're all metals. They are extremely reactive. They need to be stored inside oil because if they come into contact with air, they start to react quite quickly. And they also react really violently with water to produce an alkaline solution. That's where they get their name alkali metals from, because they produce alkaline solutions whenever they react with water. And some of them react really violently with water. In that bottom right-hand picture, you can see that's potassium reacting, and it produces this purple flame. But some of the metals, further down the group you go, they actually react even stronger, and some metals might even cause that container to explode. They react so violently. The next group we're going to look at is the group 7. So not the last group, the one next to it. And group 7, those are called the halogens. Halogens are non-metals. The rule is Elements on the left-hand side of the periodic table are metals. Elements on the right-hand side are non-metals. Now, halogens are also really reactive. They're the same reactivity as alkali metals, except they don't react with water. Now, a lot of these halogens you might have heard of. Chlorine. Chlorine is what gives swimming pools that smell, and it's used as a disinfectant, so it helps to clean away and destroy bacteria and viruses. And another halogen that you might have heard of is fluoride or fluorine. And so fluorine, when it's fluoride, is sometimes put in toothpaste, and what it does is it helps make your teeth even stronger. Next, what we're going to look at in the periodic table, we're going to look at the very final group called group 8, or sometimes group 0, and it's got another special name, and they're called the noble gases. Now, the noble gases are the least reactive gases. It's hard to get them to do a chemical reaction at all. They are described as monoatomic, and that's because, unlike a lot of elements where their atoms come together to form a structure, noble gases exist as one atom at a time, and they do not form bonds. Now, you might have heard of some of these noble gases. You've probably heard of helium balloons. Well, the reason why helium's safe to put in balloons is because it's not going to react with anything. Other noble gases are like neon. So if neon lights, the reason they're called neon lights is because the bulb is filled with neon gas, which gives it that red color. So noble gases are really unreactive. And then what we have next is this block in the middle. Now, in the middle, all of these things are metals. So the middle and the left-hand side are metals, and the right-hand side is non-metals. All these things in here are called transition metals, and they contain some of the most useful metals. So in here we've got iron, we've got copper, we've got silver, we've got gold, and we've also got titanium. A lot of the materials that are used to make things. Now, transition metals are not one group. There are lots of different groups. As metals, they can be used to make a lot of useful things, but if they form ions, which we'll learn about in another lesson, and they form multicolored ions, and you can see them at the bottom. And they're also used as catalysts, and a catalyst is something which makes a reaction go faster, but you can get it back at the end. So they're really good catalysts, and they're really important to be used as catalysts. So that was our lesson. Hopefully, you'll be able to identify what a period and a group is on the periodic table. You'd be able to identify that metals are on the left-hand side of the periodic table and non-metals are on the right-hand side of the periodic table. You would be able to give me the names of group 1, the alkali metals, group 7, the halogens, and group 8, the noble gases, and be able to describe them in some way. So the alkali metals are very reactive metals, the halogens are very reactive non-metals, and the noble gases are unreactive nonmetals. And you'd hopefully be able to also name that block in the middle of the periodic table the transition.